In this video, I'm going to explain what fractional exponents mean. I've already explained in another video what a fractional exponent means if that fraction is 1 over something, which is called a unitary fraction. So, for example, a half or a fourth or a fifth. And in this video, I'll explain it for any fractions. Okay, so the question is, what do fractional exponents mean? And that can be restated as, what does x to the exponent m over n mean? M and n, they're going to be integers. And so here we've got a base with a fractional exponent. What does that mean? Okay, to figure that out, we need sort of two pieces of information that you already know. The first one is that this exponent rule, that if we have a base and then the exponent is a product of two numbers, like 5 times 2 or m times n, then that's equivalent to a to the m, so the base raised to the first the exponent of the first number, all of that to the exponent of the second number, n. Okay, so we're going to use that rule, and then this is also just a little reminder here. Remember that m times n, a fraction, is equal to m times 1 over n. So for example, 3/4, that's equal to 3 times 1/4, or to 1/4 times 3 if you want to divide it in the other direction. Okay, so we're actually going to do an example first, and then we'll go to rule. So, 8 to the exponent 2/3. How do we figure out what that is? So, we're going to use this little idea here. We're going to write it, I'm actually going to do it two different ways. We'll get the same answer either way. I can write it as 8 to the exponent 2 times 1/3. And now I'm going to use this rule that just says I can sort of do the first part of the exponent first. So that's going to be 8 squared to the exponent 1/3. Okay, and now we're going to look at, well, what does 1/3 of an exponent of 1/3, what does that do? Well, that's a cube root. So this is the cube root of 8 squared. Okay. So far it just looks like I'm shuffling numbers around. This ideas are actually really important, but it still kind of feels like maybe we're not much farther ahead. But here's how we find the answer. We'll start on the inside. We've got 8 squared, so that's 64. So this is equal to the cube root of 64. And what is the cube root of 64? Well, it's 4. Okay, so that's one way we can find the answer. The other way is really, really similar. We just do things in an opposite order. So I'll put or. We can take 8 to the exponent 2/3, and I'm just going to write these two factors in the other order. So I'll write 8 to the 1/3 times 2. So now I'm going to use this property here. I've got 8 to the exponent 1/3 to the exponent 2. And now I'm going to write my exponent of 1/3 as a cube root. Okay. And I've got that to the exponent 2. Okay, and now I'm actually going to calculate what these are. The cube root of 8 is 2. So this is equal to 2 squared, because I've still got my squared, and 2 squared is 4. So that's perfect. Okay, so now what I'm going to do is I'm going to take what we did up here, and we're going to see what if we just if all these numbers were just variables. So what if we were looking at x to the exponent m over n? So the first way, I took my numerator and then multiply by 1 over the denominator. So I'll do that first. So I have x to the m times 1 over n. And now I'm just going to sort of evaluate the first exponent first. So I have x to the m in brackets times 1 over n. And now I'm going to take my exponent of 1 over n and write it as a radical. So it's going to be the nth root of x to the m. Okay, so that's one way of writing this. So x to the m over n equals the nth root of x to the m. The other way, which is really similar, but we use the opposite order, I'm going to write it as x to the 1 over n times m. And then I'll do the x to the 1 over n to the exponent m. And now I'm going to use my nth root there. So the nth root of x to to the exponent m. Okay, so the other thing, this can be the nth root of x to the exponent m. So these are almost exactly the same. And I mean, they always come out the same. They are equivalent, but they feel a little bit different when you calculate them. So with this version, we raise the number to the power to the exponent before we take the root. So often with this version, your numbers will be bigger. So this is usually my preferred way of doing it, where I take the root of the base first, and then I raise it to the power. Although there are a few examples when this number is I guess, impossible to do in your head, because the nth root will be something awful. So sometimes this is better, sometimes this one's better. So know that you can use both of them. Okay, good luck with it.